Basically, we can go through here. Ah, basically, I will start with week 3. I will start with week 3. Uh, I will start with week 3. Week 3 is all about clustering. Week 3 is all about clustering. Basically, clustering is an unsupervised learning method. Basically, clustering is an unsupervised learning method. Basically, clustering is an unsupervised learning method. Simply, we can have we can have uh, we can have several dot points in the plane, and with different colors. Basically, in clustering algorithm, it is an unsupervised learning. We have the several data points of different colors. Uh, Basically, I was saying there is a different there is different uh, there is different there are different data points in the plane. Uh, 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 uh. Basically, you can think as we have different news in the atmosphere, in the news channels, different cadre news, such as politics, such as games, and all. Unsupervised learning is the method in which we don't need to have an output. We cluster, either we present, we learn the algorithm to cluster it according to their more uniquely identification. You can say these are all the data points. Basically, you can consider each point as a different cadre of news, different type of news, such as sports, such as sports, media, such as modes, media. Basically, in this, we what we do now, these are all the points x1, x1, x2, xn. So basically, uh, clustering is assigning a points to a cluster. Basically, we can have the cluster like this. A different location. We can have different clusters, like this cluster, and this cluster. Basically, we can consider it is all the points which represents the news. It's all the point which represents the politics. It's all the point representing the politics. Uh, It's all the point representing the politics and all. It's all the point representing the politics. Clustering represents the essential method in unsupervised learning, machine learning, machine learning method in unsupervised that aim to group similar objects into the clusters, thereby revealing the inherent structure within the data for exploratory analysis. I'm loving out it all because it will basically it is a unsupervised learning. We don't need an output. Uh, that's why it's simple. There are n data points. There are n data points, and we have their n data points, such as n data points, 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 and each and we need to assign all these n data points in n clusters. So uh, every data point can have a z value. Every data point can have a z value, which is for first data point it will be z1. For second data point it will be z2. For third data point it can be z3. Z3. तो basically क्या है कि we have every point is assigned to a cluster. We have considered there are k clusters. Then the question is that how we can assign these points, how we can assign this point to a cluster such that it is well defined by it. Such as in media wale cluster में, in politics wale cluster में, there is no news which will have sport news. In this introduction to clustering is used basically for spam email classification. So it is very beneficial. So first of all, we have n data points. We have to assign, there is a basic concept that we, for every cluster, there will be a mean, because mean will be the x1, all the points which are in the cluster by total number of points. This formula is for the mean of the every cluster. First of all, randomly we assign any point. Randomly we assign any point to any cluster, such as uh, with zi value. Means zi means z1 means first cluster will have k value, means k will be from 1 to k. So zi is equal to k means first ith point will be in the kth cluster, kth cluster, or ith point, if zi is equal to 1, ith point will be in one cluster. Basically this this whole expression means that if a point is in the kth cluster, it value will be 1, otherwise 0. This whole point means this, and simply in the denominator part, basically it's calculate from all the I1 to n point which are in the cluster. It only consider those points and take the mean out of it. We have assigned that we have I already told that what the main purpose is, to assign all the points a cluster. Assign all the points a cluster. Assign all the points a cluster. All the points a cluster. Xi denotes the data point, Zi denotes the cluster indicator, mu Zi denotes the mean of the cluster of that indicator, S represents the set of all possible cluster assignments. Guys, if you have any doubt in between, you can stop me and ask any doubt if you want. S represents the set of all possible cluster. It is important to note that S is finite. S represents the set of all possible clusters. How it become k power n? I can explain. Have you learned about permutation and combination? every data point has key options, that it either x1 can be in 1, 2, 3, 4. Matlab, in either of one option, matlab 1, 2, 3, 4, it can be only in one option. One, either it will be in cluster 1, cluster 2, cluster 3, or any cluster less the k. So every points have the k options. So total number of representation of clusters will be k into k dot 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 n times. It is k की power n, and it is hard to compute. Matlab, we cannot directly assume that which is most important cluster, because we have to go through all k की power n options. It is an exponential function, so we cannot directly guess. So we have uh, defined more ways that how we can calculate these clusters. Basically, the goal of the this whole clustering algorithm is to minimize the distance of each point in cluster from its mean. Mu zi denotes the mean of the cluster of indicator. Means every point is closely associated to its mean. This is the goal of this whole clustering algorithm. That will only define that basically distance here defines the distance relation between the two features of two data points. Here the distance is as defining the relationship between relationship between the points on the basis of features, which if the two data points have same features, they will be nearer. If two data points will be different features, they will be farther apart. Means two news of sports will be together, will be at the less distance as compared to the as compared to the two as compared to the two data points which is farther away. Sorry, with every point our main focus will be reducing the uh, reducing the this NP hard problem, and also optimization problem, reducing this error. Basically, every cluster will try to optimize in such a way that every point is very near to its mean. So here we come with an algorithm. K means clustering algorithm. It is called. It's also called Lillard's algorithm. It is also called Lillard's algorithm. Basically, generally we randomly assign the data point from data set as initial cluster centers. Yeah, randomly assign the data point from data set as initial cluster centers. So randomly assign, I said, we randomly assign the data points, and basically, and this is a reassignment step. Basically, if we randomly assign data point to a data set to any initial clusters, we have, for example, we can say there are 4 clusters. Four clusters. 1, 2, 3. We have several data points, several data points, several data points, several data point, data point, data point, data point. These are several data points. each will have its mean. Each will have its mean at the center. Now, for every point, and data points, we need to check that. We need to check that from any of the k mean centers, is it more near than the currently assigned centers mean? From the any of the k means, any of the centers, any of the mean of the k 1 2 3 4 cluster, from where it is minimum, at minimum distance. This is whole function will is that only, that for argument is k, it will minimize for every data point, for every k, minimum distance of each data point from any of the k, and that will be the value of zit, matlab first iteration. Basically, every point will check its distance from each of the mean of the cluster of 1 2 3 4 cluster, and from where the distance will be less, it will be assigned. This is iterative step. Step 0, calculate, randomly assign any data point to any clusters, calculate the mean of each clusters. Reassignment step is step 2. After that, we have k clusters and the mean with that each and every clusters. Now, for it is iterative step. At the first was a 0 step, second is first step, in which we will check for every point that from where which mean centers it is at minimum distance. It doesn't matter that it is it from every cluster we will check. We will check with the distance between the mean from that cluster, and after that, we will reassign with the minimum distance from any of the clusters. It is the mean of kth cluster, mean of any ith cluster, and xi is the any data point. The minimum of where it will be minimum, it will be reassigned. Basically, if this is a data point, it was earlier assigned to this cluster, but we found that this distance is smaller. Whether it is not looking small, but it is smaller, then it will be at first step reassigned to the second cluster. This is the whole algorithm. Is a whole algorithm. Every step, this is the first step. For every step, we will calculate again. We have done all the reassignments. Basically, each and every point is nearer to its is in the cluster from where its distance is very much less to that cluster's mean. Basically, and now whatever the mean we have calculated earlier, on the basis of which we have done the reassignment, but now after all the reassignment, each cluster mean will change because many of the data point would have been added and many of the data point would have been deleted or gone to another cluster. So for every step, we will calculate the new mean. This is the formula for new mean. Same, we will check in which cluster it has been newly assigned, and we will do this whole procedure. And until when we will do, this is the iterative step. First line complete. After that, again we will start from 0. That now we have k clusters, k means, and now for each mean we have to, for each data point we have to assign to that cluster. Again we have to assign to that cluster whose distance from that point is less, whose mean distance from that point is less. And we will do this iterative step regularly until any new assignment is not being done. Means repeat step 2 and step 3 until the clustered assignment not change. That at any further step there will be a point that any of the clustered assignment will be not be changing. Means basically it is at its optimal. No every point in the cluster is at minimum distance from that cluster mean, and it is at farther distance from any other's cluster mean. That's why it is the minima. This is convergence of k-means algorithm. I can explain you with this. Hello. Am I audible? Hello. Basically, we can discuss it as it is. Hmm. This is whole notes which I follow. Basically, you need to follow the lecture. I think it's awesome. I highly recommend the lectures. It's awesome. Everything I've explained till now. Ladder algorithm has been explained. Convergence and देखो convergence. Basically, how we, how I am reassured that how I am reassured that this method gives me the minima of the global optimization function. This function, which where whole focus is to minimize this function, mean average of Jedi's cluster. Whole. Then what steps we are performing? How we can confirm that this step has its minima? That we have discussed the Lord's algorithm. Okay, give me 1 minute break. Let me drink water. Am I audible? Hello, am I audible? Basically, now we'll discuss the convergence, nature of the clusters, and how to optimize this algorithm also, and the choice of K. Hmm. Basically, this is the convergence step. Huh. Basically, first of all, a simple analyze, simple that if we have the K points, if we have, sorry, if we have the L, we have the x1 to x2 L points, can you find a point that it's the distance from every point square will be minimum? Can you find that point which has, if you sum the difference between the distance from each point to that point, that center point, it is minimum? Basically, we need, basically, take it as an example that we have L points, and by this method we are trying to minimize the distance. We have taken a B point which we assume, we can assume that it has, we are calculating its distance from every point, we are taking this distance square from every point, because distance can be here we are minusing and we are not seeing, so it can be plus and minus both. So here how we are calculating, we need to calculate that point which has minimum value of this V star. So how we will do this? Basically, for for the problem of uh, 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 for the problem, we will differentiate it. If we will differentiate it, 2 will come out, summation xi minus V star. It, we quit it to 0, then it will be summation xi will be same, but V star is a simple value, it's constant value, it will be LV star, and this is the whole. But to calculate any functions mean, we differentiate it. It's the simple calculus. It's the simple calculus. It's a simple calculus. Uh, so we are at iteration T. We have discussed all that every iteration we will have different cluster assignment. ZIT represent that at T iteration, what will be the assignment for the first cluster Z1T. For the first data point X1, Z will take value from 1 to K, 1, 2, 3, 4K, and Z1T will represent if the Z1T has value 3, means the first data point is assigned to third cluster at T iteration. Understood? Z1T is equal to 3, then at Tth iteration, first X1 data point, third cluster. Simple. So we have to update our assignment at each. We have to update our assignment at each of the. We have to update our assignment at each of the iteration. We know how we have discussed earlier how we have updated. So now next. Basically, this is the most important thing. This is our objective function. Basically, we are need to optimize. How first we will think how this is pretended through. We know that every reassignment step is being done to minimize because we are calculating, we are checking that only that we are checking. You can see the reassignment step. We are checking. 1 minute. At every reassignment step, we are checking that only xi minus mu tk square from which cluster mean it has the minimum distance we have reassigned to it to that point. So basically, we are only doing minimization of this function. You can think in that way. For which k this value will be minimum. Ith data point will be at minimum distance from any of which clusters. Basically, we're trying to minimize this. That's why at teeth cluster, what cluster it had been assigned, the mean, the objective function will be greater than the further iterative step, because we have for every cluster we have only ensured that point only, and we are reassigning on that basis only that at any iteration for further iteration we will assign though the data point xi to that cluster from where the mean distance will be minimum. So if we'll do summation, this if we put summation all over, this will be less. Yeah, I have proved this, that mean of the cluster when